Hello, and welcome to a video about the format of addresses in Semantic Synchrony. In an earlier video on nonlinearity, I described the correspondence between the front end of Semantic Synchrony, namely Emacs running in brain mode, and the back end, which is Gremlin server running some Semantic Synchrony code. I said the front end looks like a bunch of text like this, or like this. And the back end is a graph. So let's consider that graph in a little more detail. Semantic Synchrony, well, any graph database doesn't actually represent the graph as a bunch of dots and lines connecting the dots. That is conceptually what the data is, but there's no pictures in the graph database. Instead, each one of these objects, each one of these nodes, the colored, the circles, each one of those things in a graph database has what's called an address. And then so this one would be like at address 1, this one would be at address 2. Each one of them has a unique address. So if you know the address, you know how to get to the thing that's there. And given those, the graph database is able to keep track of edges by simply knowing where the edge starts and where the edge ends. That is, every edge, I should say connection, because edge is a confusing word, but every connection in the graph is just a sequence of the start address and the end address. In Semantic Synchrony, the data is a property graph. Over here I've got some I've highlighted the shortcuts that I think are important that I'll be using in the rest of this. Over here, I have a curriculum for myself to work through. So right now, it looks like we see everything there is to know about these nodes. We have 6 of them on the screen. Each one of them has some text, and that's all you could know, right? Well, that's not actually the whole story. I'm going to show it in property mode. So here we see that these notes, not only do they have some text associated with them, but each one has a shareability level and a weight. And in fact, you can give it other properties. You can make up your own properties. If I say this has a strange of 1.5, I can do that. I think. Oh, never mind. Maybe this? Can I do that? I can't do that? I could have sworn. Oh, pardon me. Okay, so you have a few fixed parameters that you can work with. But what I'm showing you right now still isn't the whole story. There's a little bit more data hidden in this note. So I'm going to highlight that note now. Oh, let me show you that thing. Yeah. So I'm going to highlight that note and go into another application and paste what I just copied. So we see the weight and the shareability that we saw up here, and we see the same text. We even see the plus sign. That's one kind of bullet that you could have. But what we see in the new application that we don't see in Emacs is this address, this thing from here to here, bounded by colons. That is the address of the node. That is enough information for Semantic Synchrony to know what you're talking about. So if you go into a Semantic Synchrony window and you paste just that information, Semantic Synchrony will recognize it because it's able to look up the note that resides at that address. So I just pushed that to the graph, and now we see the server uses addresses, has 2 parents instead of 1. And in this view, it would also know about those 2 parents if I update, which I just did. So now it has 2 parents. But I don't actually want it to be over here, I just want it to be on the left side. So I'm going to delete it from the right side. And now if I go back here and refresh, I see that it only has 1 parent again, which is how I wanted it. So you can refer to a note by just its address. However, you could also refer to it by the address followed by the text. And if you do that, it'll work. On the other hand, what you could do instead is you could paste that same address, but modify the text. And if you do that, then Semantic Synchrony will believe that you intend to have modified the text. Oh, what did I just do? So, if I paste that, I see that the modifications have shown up. And now if I go over here and refresh, I'll see them over there too. So that's how you can refer to a note in Semantic Synchrony using text. Now, sometimes you'll want to copy the note in its entirety. When you want to do that, there's a handy keyboard shortcut. You could just highlight the whole thing by pressing Z and then going to the end of the line and then pressing C for copy. All right, if you do that, that'll work. But there's a faster way to do it. So I'm just showing you that it worked now. There's a faster way to do that, which is to press Control-C and R. And then you've copied only the note address. So if I go into another application and paste what I just copied, you see I only got the address. So this application doesn't know what to do with that. But in this application, it'll know that that's the address of the note on line 1 in the left buffer. So if I paste that, it should appear again. Okay, so that's another way to copy something. If you want to only copy the text, there's also a handy shortcut for that, which is Control-C-V. So if I paste what I just copied, you see that there's no bullet, there's no leading bullet, and there's no address. There's only the text that was where I was. There's one more way to create a note, which is to create it from raw text. If you create it from raw text, then it doesn't yet exist in the graph. And so what Semantic Synchrony will do is invent a new address for it to reside at. I'll do this right now. I'll type a bullet, and in fact it doesn't have to be a dot, it could be anything. It could be the letter A, or it could be a 3, or it could be a hash symbol. Just as long as it's only one character, it'll work. And then I can type some text, and if I push that to the graph, we see that now we have a new note, and there's a new address corresponding to that new note. So that's how to manipulate addresses and notes, how to copy notes, how to paste notes in Semantic Synchrony. I hope you enjoyed it, and I look forward to seeing you in this application. We will merge minds. It will be great. Vulkan, Utopia. This is Jeff Brown signing off.